All right, this is our first video in the practice problems of lesson 2-1, and let's just get started here. First thing they're having us do is just simply find the value of the 6 trig functions. Those 6 of them are already shown here. They've already listed them. All we need to do is make sure we have enough information on our triangle, and then second, we need to make sure we get the right ratios with the right labels. So first things first, we need to get that third side figured out. This again, there's a few ways to do this. You might know that this is a Pythagorean triple and say that, hey, this is an 8, 15, 17 triple. Otherwise, you can just simply say, 8 squared plus x squared equals 17 squared. And to solve for x, we would take the square root of 17 squared minus 8 squared. Either way, you get 15. Now we have our 3 sides determined. Let's use those ratios. So sine is opposite over hypotenuse. So I'm going to do that over like that. Just shortened up, but at least it'll help us keep track. So here's the angle we're working with, because there are always 3 angles in a triangle. So we need to know which one we're dealing with. So that would be this one here, theta. Opposite of that would be straight across, that's 15. And hypotenuse, the hypotenuse always that longest side, so 17. I'll go down the line top to bottom because those are our 3 base trig functions. So cosine is up next. Cosine we know as adjacent. You know what I'm going to use? Is adjacent over hypotenuse. And adjacent just simply means next to. So the side next to the angle theta is 8. And again, hypotenuse is 17. So adjacent over hypotenuse becomes 8/17. Something to note, the value of the trig function is a fraction. We're not looking for an angle here. The angle is theta, and we're leaving theta as a variable. We just want to know what is the ratio whose angle gives us theta. So lastly, we have tangent theta, that would be opposite. Sorry about that. Opposite over adjacent. That gives us that ratio. The opposite, again, is 15. And the adjacent, the side next to, is 8. Now, if we continue our work, cosecant, secant, and cotangent, those 3 other trig ratios, for all intents and purposes right now, we just look at those as simply the inverses of those first 3 trig functions. So sine and cosecant are related because one is the inverse of the other. So if I have the cosecant of theta, I have the reciprocal. So I just simply take that fraction of opposite over hypotenuse and I flip that. It would be hypotenuse over opposite, or 17/15. Secant is the same idea, but with her cosine. So secant is the reciprocal of cosine, so that's hypotenuse over adjacent, so 17/8. And cotangent is inverse of tangent, adjacent over opposite, or 8/15 in this case. So that is what they're asking us for. Problem 1 simply solved. Let's keep rolling right into question 2. And there's a few things I'll note about 2 here, and that starting with, we have 4 times the square root of 15 as one of our side lengths. I would like you to continue using square roots as square roots and rather not have you leaving approximates. So for example, because I can do this without solving the rest of the triangle, I'm going to go right to tangent. And tangent, again, tangent's opposite over adjacent. So the way I would do that is I would not plug in 4 times square root 15 and get a decimal. I would just write it again. So theta is here, that's the opposite, so that's the top. I would just simply rewrite it square root 15. And then adjacent 17. So that's the first thing I want to note about problem 2. And any problems like that, when you have square roots in your problem, I would prefer you have square roots in your answer, not approximations. So with that said, let's continue solving the triangle. Let's find the hypotenuse. And to do that, here's what I'm going to do. We'll just start with writing it out. So side squared 17, so that's a 17 squared, plus 4 square root of 15 squared, and that will equal, let's just call it side squared. So when we do that, 17 squared is 289. Now, 4 times the square root of 15 as a quantity, in parentheses, as a quantity squared, what that really is, you know, if we have like, I don't know, a good example, but the rules that be say that when I have a number like 4 times a number like square root 15, and I'm trying to take that number squared, 4 square root 15 squared, really what I can do is I can break that squared component up and take it to each component. So I can take 4 squared and square root of 15 squared, and then combine those together and multiply them. So in other words, what I'm trying to say is I can take and write that as 4 squared times the square root of 15 squared. And that equals side squared. All right, so that's what I'm trying to say. And what that does is it allows us to get that square root out of there, again, without any kind of decimal approximations. So that's, I'm just going to leave room in the middle. So 289. Well, 4 squared is 16, and the square root of 15 squared is 15. So that's really, so 16 times. S equals the square root of 529. Because 16 times 15 is 240 plus 289, that's 529. So S is, I'm going to get that in red, 23. All right, so that side length is 23. Back to blue. So now we have our 3 triangle sides. I'm just going to kind of blow through these as quick as I can. So 4 square root 15 over 23, 17, 23, and we already had tangent. Cosecant, secant, cotangent, I'm just going to simply take the previous fraction and flip that. But if you look, that looks so much cleaner than having decimals to leave that square root. So again, my plug to have you doing square root exact values over decimals. And there you have it. We've solved both of these triangles. When it says find all 6 trig functions, that's really as simple as that. So what I'll do next video here, I will take the questions 3 and 4 and see if I can get those pumped out in one more video. So we'll see you in the next one.